Hello viewers, this is Wagadaronal taking you through the tutorial for A-Level Applied Mathematics. And this video, we're going to talk about the topic of motion of connected particles involving fixed and movable pulleys. So this topic is under mechanics and is suitable for students in both Senior 5 and Senior 6 offering principal mathematics as part of their combination. Now these are the very questions I left in the previous video, and I believe by now you've already tried them out and ready to mark yourself and check your progress. So question 1 says that the diagram shows a fixed pulley carrying a string which has a mass of 4 kilograms attached to one end and a light pulley A attached to the other end. Another string passes over pulley A and carries a mass of 3 kilograms at one end and a mass of 1 kilogram at the other end. Find Roman 1 the acceleration of pulley A, Roman 2 the acceleration of the 1 kilogram mass, 3 kilogram mass and 4 kilogram mass. Then Roman 3 the tension in the strings when the system is released. So the first thing to do is to show the forces acting. So let's first redraw the given diagram so that we can show the forces. So that was the given diagram. So we shall start with the weight. So this one, the weight is 4G and it's acting vertically downwards, meaning tension here will act upwards and here tension will act downwards. So now this, I think we realize that these are two different strings. This string is different from this one, meaning that there will be two different tensions. So this string will have its own tension and this one will have its own tension. That is why this time around we are putting here T1. So this will have T1 and this will have T2. So for this body the weight will be 1 gram, 1 G. G is not grams, it is acceleration due to gravity. Then because it is downwards, this will be upwards T2 and this will be downwards T2. Then for this one the weight will be 3G and here it will be upwards T2 and downwards T2. Now because these are downwards, here it will be upwards and here it will be downwards. So those are the forces acting on the particle. Now when the system is released, how does it move? So to move in this way, I think we realize that this one moves upwards, this one moves downwards, and this moves downwards, this moves upwards. So how do you know which one moves downwards and which one moves upwards? So you compare. Now for this we are going to compare this mass with the sum of all these masses. So the sum of all those masses is 1 plus 3. 1 plus 3 is 4 and this one is also 4. What does that mean? It means that they have the same mass, therefore it is up to you to choose which direction. You can choose this one to go up downwards, meaning this one will be upwards, or you choose this one to go upwards and this one will go downwards. So that works when the sum of the masses are the same. If they are not the same, you choose the one which is heavier. So according to this simulation, we took this one to go upwards and this one to go downwards. Then after that you also compare these masses alone. So this is 3, this is 1, meaning this will go downwards and this will go upwards. Okay, so now how do you know the accelerations? So for you to know the accelerations, you have to first find out what distance does each mass move. So if you look at this simulation, after a certain time t, if this one moves the distance x upwards, it means that this movable pulley will also move a distance x downwards. Now if this one, I think as you can see here, if this one alone moves the distance y the upwards and this one moves the distance y downwards, it implies that the total displacement or the total displacement will be For this side it will be y minus x. Now why are we saying y minus x? It is because this one moved a distance y upwards, but this pulley moved a distance x downwards. So the resultant displacement will be y minus x because they are in opposite directions. When you come to this side, this one moved a distance y downwards, but this movable pulley also moved a distance x downwards. Now because they are in the same direction, the resultant displacement will be the sum y plus x. Now what does that mean? Remember we said acceleration is equivalent to the displacement. Therefore that means that if this is if x is a1, this will also be a1, and if y is a2, it implies that the resultant acceleration of this body will be a2 plus a1, and the resultant acceleration of this body will be a2 minus a1. So always remember that acceleration is equivalent to the displacement. So now shall come and put the accelerations. So for this one it will move downwards and to be a1, meaning this will also move upwards and to be a1. Then for this one to move downwards, but it will be a2 plus a1, and this one to move upwards and it will be a2 minus a1. So I believe by now you'll know where these accelerations are coming from. So now that you have shown the forces and the accelerations, next is to use F equal to ma. So for the 4 kilogram mass, these are the forces on the 4 kilogram mass. It is moving upwards, meaning it will be resultant force will be T1 minus 4g. So shall come here and say that T1 minus 4g is equal to 4a1. So 4 is the mass, a1 is the acceleration. What about for the pulley A? For pulley A, these are the forces acting on pulley A. So it is moving up downwards, meaning resultant force will be T2 plus T2 minus T1. In other words, it will be 2T2 minus T1. So you are coming and write that 2T2 minus T1 is equal to 0a1. Remember, this one they told us that the pulley is light, therefore its mass is negligible. That's why you put here 0. Therefore you come up with an equation of 2T2 minus T1 is equal to 0, and that is equation 2. The next will be for the 3 kilogram mass. For the 3 kilogram mass, these are we shall consider these forces. So it is moving downwards, meaning it will be resultant force will be 3g minus T2. So we'll come here and write that 3g minus T2 is equal to 3 in brackets a2 plus a1. Now 3g minus T2 is the resultant force, 3 is the mass, and a2 plus a1 is the acceleration. What about for the 1 kilogram mass? For the 1 kilogram mass, we shall deal with this. So it is moving upwards, meaning the resultant force will be T2 minus g. Therefore you come and say that T2 minus g is equal to a2 minus a1. So this T2 minus g is the resultant force. The mass was 1 kilogram and the acceleration is a2 minus a1. So we are done with writing the equations. There are 4 equations, meaning there are also 4 unknowns. There is T1, T2, a1 and a2. So 4 equations, 4 unknowns, meaning that we can now solve them simultaneously. So when I add equation 2 to equation, so the first thing to do, I will look for eliminating the tension so that I remain with only accelerations, and I can get the accelerations first, then I get tensions next. So when I add equation 3 to equation 2, this is what I'm going to get. So T2 will cancel, then 3g minus g will give me 2g, which is that. Then this is 3a2 plus a2 will give me 4a2. Then 3a1 plus minus a1 will give me 2a1. Therefore, when I simplify, I'll come up with g equal to divide both sides, divide through by 2. I'll come up with g equal to 2a2 plus a1, and that is equation 5. What about equation 1 plus equation 2? When I add these two, this T1 will cancel, but this one will remain, so I'll remain with 2T2 minus 4G equal to 4A1, and that is equation 6. Now before we go to the next slide, let's see how mass can be awarded for this slide. So B1 for the correct force diagram, and B1 for all these 4 forces, 4 equations, and M1 for these equations, equation 5, 6, and 7. We shall see equation 7 in the next slide. So when I multiply 2 throughout equation 3 and add it to equation 6, this is what I'm going to get. So I think we realize that this cancels, this and this gives me 2G, and this 6A2 is that, then 6A1 plus 4A1 will give me 10A1. So I have an equation which has only A2 and A1, and I call it equation 7. Therefore, now I'll deal with these two equations with only A2 and A1. So equation 5 times equation 5 minus 7, equation 7 will give me this. So when I subtract 4G minus G will give me 4G, sorry, 5G minus G will give me 4G. Then 10A2 minus 3A2 will give me 7A2. Then 5A1 minus 5A1 will give me 0, so I remain with only A2 as the only unknown. I know G is 9.8, therefore A2 will be equal to 5.6 meters per second squared. Now from equation 7, this equation, I can substitute for A2 in order to get A1. So when I substitute, I remain with A1 as the only unknown. Therefore A1 will be equal to negative 1.4 meters per second squared. Therefore the acceleration of pulley A is 1.4 meters per second squared downwards. Now why are we saying downwards? It is because of this negative. So M1 is for addition, B1 is output, M1 addition, and A1 is output with the correct direction. Therefore, you're already seeing that the acceleration of pulley A is 1.4 meters per second downwards. Therefore, for Roman 2, they wanted the acceleration of all the masses, hanging masses. Therefore, A2, first of all, A2 minus A1 will be equal to this. We have to maintain the negative sign, meaning that acceleration of 1 kilogram mass is 7 meters per second squared upwards. What about A2 plus A1? It will be 4.2, meaning that acceleration of the 3 kilogram mass is 4.2 meters per second squared downwards. And acceleration of 4 kilogram mass, the same as acceleration of the pulley. Therefore, it will be 1.4 meters per second upwards. Now for Roman 3, we shall come and see that from equation 1, I'll come and substitute in this for A1 to remain with T1 as the only unknown. So when I substitute, I'll come up with that. Therefore, T1 will be 33.6 newtons. What about from equation 2? From equation 2, I'll come and substitute that and remain with only T2, which is the only unknown. Therefore, T2 will be equal to 16.8 newtons. So basically, that's what they wanted. Now let's see how mass can be awarded. So A1 for acceleration of the 1 kilogram mass, A1 for acceleration of the 3 kilogram mass, M1 for substitution here, and it's mobile, meaning it can be given at this step or at this step. Then A1 for T1 and A1 for T2. So now we shall go to question 2. Question 2 says that the diagram shows a fixed pulley carrying a string which has a mass of 2 kilograms attached to one end and a movable pulley A of mass 0.5 kilograms. So this time the movable pulley has a certain mass attached to the other. Another string passes over pulley A and carries a mass of 0.5 kilograms at one end and a mass of 1 kilogram at the other end. Find Roman 1, the acceleration of the pulley A, Roman 2, acceleration of 0.5 kilogram mass, 1 kilogram mass, and 2 kilogram mass. Then part C, Roman 3, the tension in the strings when the system is released. So we shall begin by showing the forces. So let's first redraw the diagram so that we can show the forces acting on each particle. So we shall begin with the weight. So this is 2G downwards. Here it will be upwards tension downwards. Then here to be 0.5G downwards. Here to be tension upwards, tension downwards. Here it will be 1G downwards. Here tension upwards, tension upwards. Okay, then for the pulley A to be weight will be 0.5G downwards. Then here to be tension upwards, tension downwards. So those are the forces acting on each particle. Now what about the motions? So when it is released, it's the same as the one in the previous question. So the pulley moves downwards and this mass goes up, this goes down. So this will move downwards, this will move upwards, this will move upwards, and this will move downwards. So still the displacements will be the same as in the previous question, so that is what we are going to follow. So this acceleration will be A1 upwards, here to be A1 downwards. So this side it will be A1, A2 minus A1. Why is it so? Because this one is now moving upwards. So you realize here that this one is moving upwards, but this one is moving downwards. Therefore, the acceleration will be the difference. For this side, this pulley is moving upwards, and also this mass is moving upwards. Therefore, the acceleration will be the sum. So here we shall put acceleration is upwards and is equal to A2 plus A1. Now we shall use F equal to MA. So for the 2 kilogram mass, these are the forces we shall deal with. So we shall say it is moving downwards, therefore the resultant force will be 2G minus T1. So we shall come and write 2G minus T1 is equal to 2A1. So 2 is the mass, A1 is the acceleration. What about for the pulley? So for this pulley, the forces are these ones. So resultant is moving upwards, therefore the resultant force will be T1 minus the sum of T2 plus T2 plus 0.5G. So you come and write that. When I simplify, I'll come up with that. Then I'll go to the 0.5 kilogram mass. So here we shall use this. So it's moving upwards, so resultant force will be T2 minus 0.5G. So I'll come and write that and call it equation 3. What about for the 1 kilogram mass? For the 1 kilogram mass, we shall consider this. So it is moving downwards, though, so resultant force will be G minus T2. So I'll come and write F equal to MA. So before we go to the next slide, let's see marks for this slide. So B1 for correct force diagram and B1 for all these 4 equations. Now when I add equation 1 plus equation 2, I'll come up with that. So you realize that T1 and T1 cancels. This 2G minus 0.5G will give me 1.5G. Then this one remains and it's there. This plus this will give me 2.5A1. And I'll call that equation 5. Then equation 3 plus equation 4 will give me that. So realize that T2 cancels, then this with this, So g minus 0.5 gives me 0.5g. Then this side, 0.5a2 plus a2 is 1.5a2. Then 0.5a1 minus a1 will give me negative 0.5a1, which is that. So that is equation 6. What about 3? When I multiply 2 throughout equation 3 and add it to equation 5, this is what I'm going to get. So this T2 will cancel, this and this will give me 0.5g, this will remain, and this a1 plus this will give me 3.5a1, and that is equation 7. What about when I multiply 7 throughout equation 6 and add it to 7? I'll come up with that. So the aim of doing all this is to eliminate the tensions so that I remain with only the accelerations, and I can easily get the accelerations. So when I add this and this will give me 4, this with this will give me this, and this with this will give me 0. So I only have a2 as the only unknown. So before we go to the next slide, let's see how much can be awarded. So all these 3 equations, m1, and adding the 2 and adding those equations, that is to come up with only one unknown, that is m1. So when I substitute for g, this is what I'm going to get. So a2 will be equal to 3.409 meters per second squared. Then from equation 7, I'll come and substitute for a2 to come up with a1 as the only unknown. Therefore a1 will be equal to 0.426 meters per second squared. Therefore acceleration of pulley A is 0.426 meters per second squared upwards. If I go to the next slide, let's see marks for this slide. So B1 for this output, M1 for substitution, and A1 for acceleration. So now we shall go to Roman 2. So the acceleration of the 1 kilogram mass is 0.426 meters per second squared upwards. Then when I say A2 plus A1, I'll come up with 3.835 meters per second squared. Therefore acceleration of the 0.5 kilogram mass is that upwards. Then when I say A2 minus A1, I'll come up with 2.983 meters per second squared. Therefore acceleration of the 1 kilogram mass is that downwards. Now I'll go to Roman 3. Roman 3, I'll come and say that from equation 1, when I substitute, I remain with only T1, which is the only unknown. Therefore T1 will be equal to 18.748 newtons. What about when I substitute into equation 4? So from equation 4, I'll come and substitute and remain with T2 as the only unknown. Therefore T2 is equal to 6.817 newtons. So basically that's what they wanted, and now let's see how much can be awarded. So this one for this, and this one for that, this for, now this M1 is mobile, meaning you can give it at this step or at that step. Then A1 for T1 and A1 for T2. Okay, so I believe you have marked yourself and checked your progress. So what I'm going to do, I'm going to leave you a set of questions on motion of connected particles involving horizontal planes. So we have been dealing with hanging masses. Now we shall deal with when they add there a horizontal plane. So that brings us to the end of this video. Thank you for watching, and be reminded that the solutions for the assignment left will be available in the next video. So if you have not yet subscribed, please click on the subscribe button below this video so that you can receive updates when the next video with the solutions has been uploaded. And also, if you know of any student who's not yet on this platform, please share the link of this video with them via social media platforms like Facebook and WhatsApp so that you can all benefit as a family.